Okay, this is question 8.7, number 1. It's about wind power. All right, and I started partway into this question. The first part of the question asked about how you convert the kinetic energy from the wind into electrical energy. All right, and what happens is the wind blows through the wind turbine, okay, and the wind has kinetic energy. It converts that kinetic energy into rotational kinetic energy in the blades, which turns a dynamo inside the little box here, and that turns the kinetic energy into electrical energy. All right. Now on to question 2. Air of density rho and speed v passes normally through a wind turbine of blade length r as shown below. Deduce that the kinetic energy per unit of time of the air incident on the turbine is 1/2 pi times rho times r squared times v cubed. All right, that's a long equation there. So I highlighted the givens in blue here. I highlighted the unknown in green. Okay, I have to show that this is actually the kinetic energy per unit of time. All right, so here's my evaluate step. First of all, the volume of air that flows through here each second, or the volume of air that flows through here per unit of time is a cylinder with area of pi times the blade length r squared. All right, and the height of the cylinder, or I guess in this case the length of the cylinder, is equal to the velocity in meters per second. Okay, so it's the distance covered by the wind in 1 second. That's the amount of air that will blow through. All right, so you're talking about a cylinder with this area and the distance that this velocity will cover in 1 second. All right, so the volume of air is equal to v times pi times r squared. All right, the velocity times pi r squared. Okay, now the mass of that air, evaluate stuff, the mass is equal to the density times the volume of air. So the density times v pi r squared. Okay, it's density times this, which is actually this. Okay, so we've added one more variable to our equation. Okay, now that we have the mass, we know that kinetic energy equals 1/2 mv squared. All right, so Ke equals 1/2 times rho v times pi r squared, this is m, right, times v squared. Okay, Ke equals 1/2 rho times, I'm going to multiply this v times this v squared at the end, rho times pi r squared times v cubed. All right, Ke equals 1/2 pi times rho times r squared times v cubed. Same thing. Okay, there we go. See you in part 2 of question 8.7.